Hello everyone, my name is Gamanji, and currently I am the ecosystem advocate for CNCF, or Cloud Native Computing Foundation. I've joined CNCF last year, and my mission is to make end users successful while at the same time bridging the gap between the adopters and the projects within the ecosystem. As well, I have many roles within the community. One of them is being an advisory board member for Captain, which is a sandbox CNCF project. As well, I'm collaborating with OpenUK, making sure that open standards are used fairly across data, hardware, and software. And last year, I've had an association with Udacity to create the Cloud Native Fundamentals course, pretty much making sure that anyone with little programming experience will be able to navigate the Cloud Native landscape. Now, I've mentioned the end-user community. This is the community that I'm working on a daily basis, and these are the adopters of Cloud Native. And I would like to give a brief introduction of what they actually do. So the end-user community currently is constructed of more than 160 organizations that use Cloud Native to produce and deliver their products and services. But more important, they are vendor neutral. It is the largest end-user community out there, and it is at the CNCF's core of end-user-driven open source. What it actually means is that we're going to look towards these organizations to define the production experience, but at the same time to grow the projects within the ecosystem through organic adoption. I'm not going to talk too much about our end-user community, but if you'd like to find out more details, go to cncf.io/end-user. We'll be able to find more details on how to join our end-user community, the member benefits, and you will be able to explore all of our current members as well. Now, let's get to the main topic. Today, however, I would like to talk about GitOps, one of the GitOps cloud native tools, and more specifically, how can we use this for infrastructure provisioning and application propagation towards the edge devices. And to do so, I would like to give a brief introduction of what GitOps actually means and the tools that currently support these capabilities. So I'm going to talk about Argo Cd and Flux. Then I would like to apply the GitOps strategy to real case scenarios. So I'm going to talk about how can we use GitOps for infrastructure provisioning. So how can you create your cluster using GitOps? And in this particular case, I'm going to focus on ClusterAPI and Flux. The second scenario I would like to showcase is how can we push applications towards the edge devices. And in this particular case, I'm going to talk about KubeEdge and Argo Cd. Now, just as a very quick show of hands, how many of you here have heard about ClusterAPI or used ClusterAPI? Well, I see a couple of hands. How many of you have used KubeEdge or heard about KubeEdge? Not so many. Awesome. And how many of you are using GitOps at the moment? Awesome. Okay, that looks quite good. Now, before I actually go and jump into the GitOps capabilities, I would like to introduce the ecosystem that allowed these principles to be developed. So if we look 6 years ago, the container orchestrator framework space was very heavily diversified. We had tools such as Docker Swarm, Apache Mesos, CoreOS Fleet, Kubernetes, and all of them provided a viable solution to run containers at scale. However, Kubernetes took the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly for its approach towards declarative configuration and automation. And this has been extremely beneficial for Kubernetes, and we can see it in numbers as well. Based on the CNCF survey last year in 2020, more than 83% of the organizations are using Kubernetes in production. When you're looking into the development community, more than 2,500 engineers are actively collaborating towards future build-out and bug fixing. And when we look into the end-user community, more than 41,000 attendees were registered at the KubeCons around the world. Now, for those of you who are not familiar with KubeCon, this is pretty much the flagship event that we use to gather all of the adopters, maintainers, contributors in one place. And we run this conference across 3 different regions. So we're going to have it in North America, Europe, and China. Of course, for this year, we run all of these events virtually, which allowed us to have a wider audience. So we reached a total of 41,000 attendees, which is a great number for our community. So this flourishing community has been extremely beneficial for Kubernetes because over time, multiple tools were built around it to extend its functionalities. We're talking about container runtimes, we're talking about storage, service mesh, observability, and all of these tools created what today we know as the cloud-native landscape, which resides under the CNCF umbrella or Cloud Native Computing Foundation. Now, at this stage, we can see an ecosystem that is focused on extending technical functionalities. But at the same time, the community realized that there is a need to improve the developer experience. So how exactly we deploy these cloud-native components? And this pretty much created the need for a simplified way to deploy our applications and even infrastructure. And this is pretty much what resulted with the GitOps strategy. Now, when we talk about GitOps, this is pretty much a strategy that has the Git repositories as the source of truth for the desired state of the application. What it actually means is we're going to have a PR-based rollout. That means that the delta between your local environment and the production cluster is just one PR away. As well with GitOps, we have the automatic reconciliation. So the way GitOps works, it's going to watch a repository, and if new changes are identified, for example, you pushed a new commit, these changes are going to be identified, extrapolated, and applied to the cluster straight away. But more importantly, with GitOps, we have a version state of your cluster and applications. That means you have different historical data points that you can easily revert to if something goes wrong in production. So you can revert to your green state just using a couple of Git commands. When we're looking into the cloud-native ecosystem, the GitOps principles are supported by two tools, Flux and Argo Cd. Flux has been donated by Weaveworks and currently is an incubating CNCF project, while Argo Cd was donated by one of our CNCF end-user organization, Intuit, and as well currently is an incubating project. I'm not going to focus into both of these tools because mainly they provide the GitOps capability, so pretty much what we've talked about today. However, we're going to see some configuration files for Flux and Argo Cd during the live demos. Now, at this stage, we have a basic understanding of what GitOps does. Let's actually see it in action. How do we actually achieve that automatic reconciliation? How do we store the state of our clusters and applications? And the first scenario I would like to showcase is how can we create a Kubernetes cluster using ClusterAPI, and how can we push changes to this cluster using Flux. So some of you might have heard about ClusterAPI. So just to make sure that we have a good basic knowledge or ground understanding, I'm going to give a brief introduction of ClusterAPI and what it actually does. Now, ClusterAPI provides a set of declarative APIs for cluster creation, management, configuration, deletion across multiple cloud providers. So they aim to provide that one interface, one set of resources that will be able to use to describe your infrastructure in different cloud providers. When we refer to ClusterAPI, we refer to SIG Cluster Lifecycle, which had its first initial release in April 2019. Since then, they had a couple of releases, and pretty much recently, it happened 2 weeks ago, they reached the beta state. So currently, they provide an API version, which is in V1, Beta 1 endpoint. And I've mentioned the ClusterAPI integrates with different cloud providers, and currently there are 17 providers that actively collaborate and integrate with ClusterAPI, from which we're going to have the major cloud providers, such as AWS, Google Cloud, Azure. If you'd like to deploy your application bare metal, we have providers such as Metal Free and Packet. And if you try to deploy your infrastructure to China, which is a very challenging task, ClusterAPI simplifies this and integrates with some of the Chinese providers such as Alibaba Cloud, Tencent, Baidu Cloud, and many more. Now, let's look at how ClusterAPI works. Supposedly, you'd like to create a couple of clusters in different regions, different cloud providers. The first thing you need to do is to create a management cluster. Now, for testing purposes, you can use Kind to create a management cluster. And Kind is just a Dockerized version of Kubernetes. You can use it locally. However, if you like to use ClusterAPI in production, it is recommended to use a fully fledged Kubernetes cluster, mainly because it comes with a more sophisticated recovery and failover mechanism. Once we have our management cluster, we'll require to install the ClusterAPI dependencies on top of it. And these are seen as controllers. And currently we have 3 sets of controllers that we require for ClusterAPI. The ClusterAPI CRDs, the Bootstrap Provider, and the Infrastructure Provider. ClusterAPI introduces 5 new custom resource definitions, or CRDs, and we'll require a controller for each of them to make sure that we can create, delete, or reconcile any changes to these resources. Now, this is going to be the first set of controllers. The second one is going to be the Bootstrap Provider. And this is the component that translates the YAML configuration into Cloud Init script, and it will make sure to attach an instance from a cloud provider to the cluster as a node. And currently, this capability is provisioned by kubeADM and Talus. And the last set of controllers we require is the Infrastructure Provider. And this is the component which actually communicates with the provider APIs and creates the actual resources. And we talk about VPCs, security groups, subnets, load balancers, and so forth. So if you'd like to create clusters in different cloud provider, you'll require a controller for every single one of them. Once we have our dependencies or controllers installed, we'll be able to provision our target clusters, and this is going to be the result. These are going to be the clusters you will deliver to your development team to deploy their application, and these are going to be the clusters your customers will interact with while they're using your products and services. Now, the most important thing about ClusterAPI is the fact that it introduces the concept of cluster as a resource. Pretty much you will be able to use YAML configuration to describe the state of your infrastructure. And it does so by introducing those 5 custom resource definitions that I've mentioned. And we actually will be able to see them in this diagram as well. So the first component we'll require, or the first resource we need to configure, is going to be cluster. And this is the component which pretty much takes care of all of the networking components. So we'll be able to specify the CIDR for our pods and services and any DNS suffix. Now, with any cluster, by default, we require a control plane. So we're going to have a set of master nodes. So the control plane resource pretty much allows us to programmatically manage a set of master nodes. And this is, you can think about this as a deployment across a set of machines, because the machine resource here that we have on the top is the actual instance. So we'll be able to specify the version of Kubernetes we want to run, the instance type, the availability zone we'd like to deploy this instance to. So all of this configuration that closely relate to an instance. Now, once we have our control plane, we might require our data plane as well. And in ClusterAPI, this is managed with a machine deployment. The concepts are very similar to some of the resources we already have in Kubernetes. So machine deployment is very similar to a deployment, which means it comes with a very powerful rolling out strategy between the machine set resources. Machine set, you've guessed it right, is very similar to replica set. Pretty much it makes sure that we have an amount of machine resources up and running at all time. And machine, as previously mentioned, is the instance configuration. We'll be able to specify the version of Kubernetes, instance type, but more importantly, the labels or the category of these nodes is going to be a worker node. Now, here we have the ground understanding of what ClusterAPI does and how it actually works underneath. I would like to give a demo overview to make sure that we have this kind of ground setup understanding while I'm going to go through the live demo as well. So currently, as mentioned with ClusterAPI, will require a management cluster. And currently, this is going to be on my local machine, and I'm going to use kind to create this cluster. On the management cluster, I'm going to have the ClusterAPI controllers, so the ones for the CRDs, the Bootstrap Provider, and the Infrastructure Provider. And I'm going to deploy a cluster to AWS. So I'm going to use the AWS Infrastructure Provider. As well with ClusterAPI, we've learned that we can define the state of our infrastructure using YAML manifests. And these YAML manifests, I will be able to store in Git. In this particular case, it's going to be GitHub, which means we're going to have those historical data points that will allow us to make the best of the GitOps strategy. As well, since I have YAML manifests, that means that I can template them and parameterize them. So for this particular example, I've used a Helm chart to template some of the parameters in this Helm chart, and which will allow me to have an input file to pretty much extrapolate our configuration that we'd like to input for our cluster. And as well in the management cluster, I'm going to have Flux Cd installed. So Flux here is going to identify any changes that I produce to the Helm chart in the GitHub repository. And once identified, they will apply them to the target cluster. So the target cluster, again, this is going to be the component that we will deliver for our developers to deploy their application, and the customers will interact with it. Now, at this stage, I have deployed the target cluster already, mainly because it takes around 10 minutes to have a full deployment of ClusterAPI to actually create the VPC and so forth, which can take a bit of time. So what I'm going to showcase in this demo is change the amount of worker nodes I have for my cluster. So I'm going to change the Helm chart within the GitHub repository. These changes are going to be picked up by Flux and applied to the target cluster in AWS. However, before I move to the live demo, I would like to showcase the Flux configuration that I'm going to use to ensure the GitOps strategy is implemented. So the way Flux works, it requires two sets of configurations. The first one is to define where you store your configuration. So where is your state, the source? The second set of configuration is the release strategy. So how exactly you would like to deploy those components. So to begin with, since I have a Git repository, which will store the Helm chart, I'm going to use a source controller. And because we're going to use a Git repository, the CRD is going to be a Git repository as well. So the type of our CRD. So here I have a CRD, which is Git repository with the name copy AWS repo. In the spec section, you can see that we have an interval of 30 seconds. So we're going to watch this repository every 30 seconds for new changes. And towards the end, we actually have the URL towards our repository, which is ClusterAPI Helm chart, and we're checking out on the main branch. The second set of configuration required with Flux is the release strategy. So how exactly we would like to deploy these components. Since I'm using a Helm chart, I'm going to use the Helm controller capabilities. However, if you use customize, you'll be able to use the customized controller capabilities. So again, depends on what you're going to actually use. So in this case, I'm going to have a Helm release custom resource definition with the name copy AWS Helm. We have an interval of 30 seconds. Again, we're going to watch this repository for any changes every single 30 seconds, and we're going to apply them thereafter. And of course, we need to be more specific with the location of the chart. So here we actually provide the relative path to our chart within the Git repository that we defined in the previous slide. So the chart is going to be within the charts/copy AWS folder. And we use an input file, or the values file for Helm, which is value-demo.yaml. And towards the end, we pretty much have the source reference, which is copy AWS repository that we defined in the previous slide. And I think this is a cue for the live demo. Hopefully everything is up and running. Cool. I hope this is going to be seen by everyone, but I'm going to walk through all of the details that I have here. Now, to begin with, I would like to go to the Helm chart. So for anyone who is not familiar with the Helm chart, this is a way to store all of your templates, but at the same time to parameterize them. So with ClusterAPI, for example, let me just make this a bit bigger. We'll be able to have that cluster resource that I've mentioned before. So we'll be able to provide the CIDR for our pods, and we associate our control plane with it as well. Very straightforward. I'm not going to go into details how ClusterAPI works, but if you have any questions, I'm more than happy to answer them. What I want to show is how we template these parameters or this manifest using Helm. So for example, the amount of replicas, this is the way we'll be able to pass the amount of replicas from the input file. And this is, for example, how we'll be able to pass the Kubernetes version. So pretty much we parameterized different variables within this manifest. For this demo, I just chose to parameterize the amount of replicas and the Kubernetes version. And we had the values-demo YAML file that I've introduced, or I've referenced within the Helm release configuration. So what we have here is the Kubernetes version, which is 1.22.0. We're going to have 3 master nodes, so 3 nodes which are going to be part of the control plane. And currently, we're going to have only 1 node, which is going to be part of our data plane. So let's go back to our terminal. I'm just going to cancel this one. So this is like a shorter overview of what I currently have, because I've deployed the target cluster, so this is going to be the target cluster. What I'm actually getting here is the machine resources. So you might see here that I have 3 control plane machines, so these are going to be the master nodes. And I have 1 machine, which MD here stands for machine deployment. So a machine which is managed by a machine deployment, which we know is going to be a data plane. And currently, we have only one of those instances. And what you can see towards the bottom pane here is all of the logs coming from Flux source controller. So if new changes are going to be identified, we'll be able to see these logs within the source controller. And as mentioned, what we want to do in this particular demo is change the amount of replicas from 1 to 3. So I'm just interacting with my Helm chart. Another thing with Flux, it's actually quite important to increase the chart version. Otherwise, it will not identify those changes to the input values file. So very straightforward, we're just going to increase the version here to 1.0.22, and I'm going to commit these changes. So very meaningful message, demo, and I'm going to do a git push. Very straightforward. I'm not going to talk about git commands here. So now if you go to, actually let me do a watch as well. The view I know it's kind of broken in lines, but what I want to showcase is the real-time update to our infrastructure and how new machine resources are going to be deployed. So now we have a log line coming from Flux in the bottom pane, and we can see the reconciliation already finished. So everything is looking great. And you might see that we already have some machines which are in the provisioning state. So if I do a kubectl get machines, I'll be able to see that we have 2 of those machines being provisioned. And we can further confirm that by going to AWS. Let me just increase that a bit. So if I do a refresh here, I should be able to see that I have 1, 2 machines which are currently initializing. And this is pretty much the way we'll be able to change our infrastructure state by using Git and the power of Flux, Flux Cd, of course. And if you wait for another 1 minute, pretty much all of these instances are going to be up and running and added to the cluster straight away. So I'm not going to, well, we actually have them all running. So it's already been added less than a minute ago. And this pretty much concludes the demo. This is what I wanted to show. How can we update our infrastructure using ClusterAPI and the power of Flux? That was actually straightforward. I thought it was going to take a bit longer to get those updates in. Now, the second scenario I'd like to showcase is how can we push changes towards edge devices. And for this particular example, I'm going to use KubeEdge and Argo Cd, both of which are incubating CNCF projects. Again, I would like to have this brief introduction of KubeEdge just to make sure we have that ground knowledge established. So KubeEdge was built on top of Kubernetes to provide synchronization of application, metadata, and networking between the cloud and the edge. So the way it actually does this is through seamless communication between the cloud and the edge components. What it actually means is if I want to deploy any new applications or push any new features to the edge, the only thing I need to do is communicate with the cloud side, which will have a Kubernetes cluster. The KubeEdge will pretty much push and proxy all of these changes seamlessly without end-user interaction. As well with KubeEdge, we're going to have the edge autonomy. That means we have these 2 components, the cloud and the edge. That means if the cloud side is going down or the connection between the cloud and the edge is interrupted, the application on the edge is still going to be up and running without any issues. So very similar to how Kubernetes works. If the control plane goes down, that doesn't mean your application on the worker nodes goes down. They're still going to be up and running. Very similar concept. And KubeEdge was built to be running on low resources, such as CPU, memory, and bandwidth. As well, I would like to give a brief introduction of the Cubat architecture and all of the components that we're going to have They're going to be useful during the demo. So with KubeEdge, we have three main components: the cloud, the edge, and the devices. The edge and the devices is the edge, but since the devices are physical components that reside with the end user, I like to differentiate them. Now, on the cloud side, we're going to have a Kubernetes cluster up and running, and this is going to be communicating with the Cloud Core components from KubeEdge. The Cloud Core components will integrate with Kubernetes API, pretty much talk with the cluster, and propagate any changes to the edge components. And this is going to be done using a WebSocket. Now, on the edge side, we're going to have the edge core components that's going to talk with the container runtime engine. So pretty much the tools that will manage our containers on the edge side. And it will talk with the MQTT client as well. So the components or the applications at the edge are going to be managed as containers, but they're not going to be managed by Kubernetes. And this is why we need a runtime, which is completely different, running on the edge. And currently, KubeEdge integrates with 4 of those runtimes, from which we have Docker, Containerd, CRI-O, and Vertlet. As well, the edge core components will talk with the Mosquito client, just to make sure that we synchronize the state of the device with the actual configuration that we defined within our manifests. Now, this is a very brief introduction of KubeEdge. Pretty much we need to understand some of the components and how it actually works. I would like to provide a demo overview. So what is exactly my current setup that I'm going to use to showcase the demo? So in this instance, I'm going to have 2 instances. One of them is going to represent the cloud. The other one is going to represent the edge. On the cloud side, I have a Kubernetes cluster up and running. And I've already installed the Cloud Core components from KubeEdge. So it will already communicate and integrate with Kubernetes. As well, on the cloud side, I'll have the Argo Cd already installed. So pretty much if I would like to deploy any applications on this Kubernetes cluster, they can be easily managed by Argo. When I'm looking to the second node, the edge side, I'm going to have the edge core components already installed, and I'm going to have Docker as the container runtime of choice. So any applications that are going to be pushed towards the edge or updated towards the edge are going to use or are going to be identified as Docker containers. And throughout the demo, what I'm going to do, I'm just going to push an application to the edge using Argo Cd. And if we have time, seems like we have time, I'm actually going to update the image of our application, and we'll see how this is deployed towards the edge side as well. And again, before I move forward, I would like to showcase the Argo Cd configuration that we'll need to use to deploy these changes. So Argo Cd pretty much uses this application CRD to define the state, destination, and a sync policy. So here we have an application customer source definition with the name Nginx Edge. In the spec section, the destination is streamed, pretty much just to shorten the output. I couldn't fit it in the slide. But in the source, we see here that we reference our Git repository, which is KubeEdge Argo Cd demo. And we have a path which points to manifest folder. So all of our configuration is going to be stored within the manifest directory within this folder or Git repository. And towards the end, you can see that we have a sync policy that is set to automated. That means that any changes that we push to for this application, they're going to be identified by Argo Cd and applied straight away. However, with Argo Cd, we have this choice of manual reconciliation. That means that we'll be able to validate our changes before they're pushed towards the production cluster. And I think this is the cue for the second demo. Let's see if everything is still up and running. So, as mentioned, I'm going to have 2 nodes. One of them is going to represent the cloud, which is going to be on the top pane, and one of them is going to represent the edge, which is going to be the bottom view. So to begin with, on the cloud side, we're going to have a Kubernetes cluster up and running, which means we'll be able to use the kubectl commands to interact with it. So if I do a kubectl, get pods in the Argo Cd namespace, we'll be able to see that we have all of our pods for Argo Cd. If I do a kubectl get pods in our default namespace, I have no applications currently deployed. I'm going to deploy them to the default namespace. However, what I would like to show is our nodes in this cluster. So by default, I have one cluster with one master node already installed. However, you can see that my edge component has been added to the cluster as a node, and we can see that it has the role of an agent and edge. Now, on the edge side, as mentioned, we're going to have no Kubernetes cluster. So if I do a kubectl command, for example, it's not going to find it. However, we're going to use Docker to manage our applications. So if I do a Docker PS, I'll be able to see currently I have no containers up and running, but we will deploy them. So let's see what we're actually going to deploy. So currently with Argo CD, we have no applications up and running. We're going to change that shortly. But I wanted to showcase what we're actually going to deploy. So within the manifest folder, we just have a very straightforward deployment. It's just going to deploy Nginx. And it's going to be in version 1.20.1. So nothing groundbreaking. We're just going to have one replica of an Nginx pod. Cool. And to deploy that, we're going to use this application CRD. Pretty much what we've seen in the slide. Maybe I should showcase, this is the destination configuration. So the destination is going to be just the current cluster. Cool. So what I'm going to do is actually deploy this application CRD using kubectl commands. So I'm going to do a kubectl apply-f, our application.yaml file. Going back to our Argo CD view, we'll be able to see, maybe I can make this bigger somehow. I'll be able to see that we have an Nginx edge deployment with a replica set and one pod. And if I click on the pod, I'll be able to see that I have version 1.20.1. Sorry, I have a runny nose for some reason. And I have no tissues. It's fine. Cool. So what we actually can do here as well is update our deployment version. So if I go to our manifest.nginx deploy, and let's go to image, we can change our image version, for example. Oh, actually, before that, let's validate what we've done here. So if I do a kubectl get pods, I'll be able to see that one pod, which is the Nginx pod, but if I do a wide output of this, I'll be able that it has been deployed to the edge node. So straight away propagated to the edge, but we didn't do anything on the edge. And if you look on the edge side, if I do a Docker PS, I'll be able to see that I have two containers. One of them is going to be the Nginx edge, and the other one is going to be the post containers, pretty much making sure that we store our IP. I'm just going to take a moment to self-maintenance. Thank you. Thank you very much. Sorry about that. Cool. Now, so what we actually see here is application was pushed to the edge. We just interacted with the cloud side, and everything was done by Argo. We didn't do anything, hands off. So another thing that we can do is, for example, if you have new features to your application, usually going to have a new image. And what you just need to do is to update that image version within your deployment. So let's do that very quickly. Supposedly I have a new tag, and I would like to deploy the Alpine version of Nginx in this case. Very straightforward. I'm just going to use the git commands to commit this. Very meaningful demo message. And I'm going to do a git push. And straight away, I'm going to go to the Argo CD view. So the sync policy that we've seen in the slides is set to automated. That means that it will look at this repository. I think it's going to look every single minute or 30 seconds. And if these changes are identified, they'll be pushed straight away. We can enforce that kind of sync policy to the Git repository. So we just hit refresh. It went to the Git repository. It found a new commit. And as we can see, it already spun up a new replica set in version 2. And we're going to have a pod already up and running. So if you click on this, we'll be able to see that the version of it is Alpine, so the latest version that we've pushed. And we can further validate that by looking into our cloud side. So we're going to have a new pod created 30 seconds ago. And again, it's going to be pushed to the edge. And if I go to the Docker, to the edge side, and do a Docker PS, we'll be able to see, again, the trim is a bit stacked, the output is a bit stacked here, but what we can actually see is we have two new containers, Docker containers. One of them is going to be for Nginx with the Alpine version, and all of the previous containers that we had for version 1.20, they just exited, so they no longer running up at the moment. And I think this is pretty much what I wanted to showcase when it comes to application propagation towards the edge. And this pretty much concludes my talk. Just as a very quick recap, we started by looking into the ecosystem that allowed the GitOps strategy to be deployed or created. And we looked into tools such as ArgoCD and Flux, which currently support those capabilities. But more importantly, we looked into real case scenarios into how can we deploy our infrastructure to the infrastructure using ClusterAPI and Flux CD. And the second scenario we looked into is how can we push changes to our edge devices using KubeEdge and Argo Cd. And all of this has been possible because GitOps at the moment is the moving force that redefines the way we deploy our cloud-native components. But more importantly, it is declarative, automatic, and reliable. And if you'd like to reach out, I'm going to actually write a Medium article with more details on how to actually set up these demos locally, if you choose so, if you'd like to play with them. So watch out on the Medium space. As well, I'm going to be available on social media such as Twitter and LinkedIn if you have further questions after the conference. And that's pretty much it. Thank you very much. I look forward to see how you can shape the cloud-native ecosystem, and I hope you're going to have an extraordinary conference. Thank you.
Thank you, Katie. Thanks a lot for the demo.
Yeah, yeah.
If we have a lot of questions to Katie. Je te laisse y aller.
What is the pricing of Argo Cd and Flux?
What is the difference? Or what
pricing.
Pricing. Both of them are, well, this is the power of cloud native. So both of them have been donated to CNCF. So there is an open source version of them, which means you have to pay nothing. It has a free license, so you can use it in your production systems very easily. You can contribute to it as well. However, both of these tools, they have an enterprise version. So, of course, the organizations, they want to monetize on some of this. So they may be able to provide support, or they might be able to provide a platform that is fully, for example, with Flux CD, they have a GitOps core platform that is fully focused on how can you use Flux on a paid version. But by default, all of it is free. It's cloud native, so it's free. Hello.
I was just wondering, are they interchangeable, Argo and Flux? So they're equal in possibilities?
Yes, absolutely. So the demos I've provided today is using ClusterAPI and Flux and using Edge and Argo CD. The thing is, you can completely switch these GitOps tools. It was mostly for me to provide an actual example. You can use them in both scenarios, so they're interchangeable in terms of functionalities. Now, Argo Cd and Flux, they provide the GitOps capabilities. So again, we're talking about reconciling your state, actually making sure that you can define your state in a repository and watch it for new changes and apply those straight away. So these capabilities, they're the same. The way they're going to achieve that is going to be quite different because Flux has its own set of controllers and Argo Cd has its own set of controllers. So underneath, they're very different tools. And you actually have seen in the configuration files that I've showed. For example, for Flux, you need 2 configuration files, one to define the state and one to define the release strategy. While with Argo Cd, you're just going to have one configuration, which is going to have everything. So there are going to be changes in the way you use the tool, in the actual way you're going to configure those particular manifests. But underneath, if you're looking for GitOps, these are going to be the tools that you can use. So in the core capabilities, I would say no, but if you're looking into quite niche capabilities, it's going to be different. With Argo Cd, maybe one feature that I can mention is going to be the UI. Argo Cd has a UI, so you can straight away look at it, and I click on it. You can interact through the command line if you choose so, but you can use the UI as well. Flux currently is working on a UI, so I'm not sure if it's been released, but they are working on this. So, this is kind of differences. Yeah, depends on what your preference and flavor is for your clusters.
You actually used ClusterAPI to provision new nodes in a Kubernetes cluster.
Yeah.
And you mentioned that you can also define other resources like a VPC or in AWS or something else. So can you use ClusterAPI and in this example Flux to provision other services in the clouds, and can you use it finally as an alternative to Terraform, for example?
All right, I see. I'm inclined to say no, because the way, maybe one thing I need to specify about ClusterAPI. So those manifest, for example, the cluster resource that I've showcased, we can specify, for example, the CIDR for our pods. But that cluster resource already is configured with the AWS provider to produce a VPC. Like all of this is kind of happening underneath the hood. So that controller will take care for for a VPC to be created, for a security group to be created. So this has been already kind of packaged within the controller and the requirements for ClusterAPI. And this is why we actually have all of these components deployed when we have a cluster. Can you use Argo Cd or Flux to replace? No. So the thing is, again, the way GitOps works, it pretty much allows you to synchronize YAML manifests. And this is kind of the most important thing about it. Terraform is slightly different. It's a different way to represent your infrastructure as code. But this is why I introduced ClusterAPI, because it's very different from that regard. You can define your state, you can define your cluster using YAML manifests. You don't need to use Terraform or Ansible. You're going to use YAML manifest instead. And this is why we can use GitOps strategy on top of it and completely automate the way we deploy our infrastructure. So hopefully that's clear on this side. Yeah, the short answer is no. But ClusterAPI, because you have YAML manifest, you can use any operations you do in Kubernetes. For example, Helm, customize all of these things, GitOps, we can use them on top.
No question? It's okay. Thank you, Katie.
Thank you very much for having me.
Thank you.
Thank you.